everyone. Welcome to your first math lesson on combining my terms. This is Mrs. Damavandy. Okay, so we're going to get started with this video. While you watch it, I want you to think about what you're noticing and then what you wonder about what's going on. Okay?
Hi, welcome to Burger Nation. How may I help you today?
Let me get 2 hamburgers with just pickles, 2 cheeseburgers with another cheeseburger, everything on them, 4 more hamburgers with everything, a cheeseburger with no pickles, and cheeseburger with nothing but pickles, 2 more hamburgers with everything but onions on one, everything but pickles, mustard, and tomatoes on the other, 3 large fries, 6 medium fries, 1 large fry, a junior fry, and 2 junior fries, 3 more cheeseburgers with extra cheese and bacon, 2 more junior fries, a hamburger with everything, 2 more hamburgers with everything, and 2 more hamburgers with everything, 4 large Cokes and a large Sprite, 2 large Cokes and a small Sprite, 5 large Cokes and 1 large Coke and a small Coke, 3 small Cokes and a small Coke and a small Coke.
Okay, will that be everything?
Yes.
Gotcha. That's 2 hamburgers with just pickles, 2 cheeseburgers with another cheeseburger, everything on it, 4 more hamburgers with everything, a cheeseburger with no pickles and a cheeseburger with nothing but pickles, 2 more hamburgers with everything but onions on one and everything but pickles, mustard, and tomatoes on the other, 3 large fries, 6 medium fries, 1 large fry, a junior fry, and 2 junior fries, 3 more cheeseburgers with extra cheese and bacon, 2 more junior fries, a hamburger with everything, 2 more hamburgers with everything, and 2 more hamburgers with everything, 4 large Cokes and a large Sprite, 2 large Cokes and a small Sprite, 5 large Cokes and a small Coke, 3 small Cokes and a small Coke and a small Coke. Is that correct?
Not quite. I wanted 2 hamburgers with just pickles, 2 cheeseburgers with another cheeseburger, everything on them, 4 more hamburgers with everything, a cheeseburger with no pickles, and a cheeseburger with nothing but pickles, 2 more hamburgers with everything but onions on one and everything but pickles, mustard, and tomatoes on the other, 3 large fries, 6 medium fries, 1 large fry, a junior fry, and 2 junior fries, 3 more cheeseburgers with extra cheese and bacon, 2 more junior fries, and a hamburger with everything, 2 more hamburgers with everything, and 2 more hamburgers with everything, 4 large Cokes and a large Sprite, 2 large Cokes and a small Sprite, 5 large Cokes and 1 large Coke and a small Coke, 3 small Cokes and a small Coke and a small Coke.
Oh, okay, that's 1 large Coke. Sorry, got it now. Is that for here to go?
I'll have it here.
Okay, that'll be $207 even, sir.
Ooh. You know what? I only have $196 on me. I'm like 11 bucks short.
Okay, well, if we got rid of 5 large fries and 4 large Cokes, that would be $11. Or 3 cheeseburgers and 1 small Sprite would be $11.
Okay, what about 2 large Cokes, 2 cheeseburgers, and 2 large Cokes?
No, that's $13.11.
What about 2 large Sprites, 2 cheeseburgers, and 2 large Sprites?
That would be the same.
$13?
$13.11.
All right, take out the 3 cheeseburgers and a small Sprite.
Oh, okay.
Oh, wait. So now I'm getting 2 hamburgers with just pickles, 4 more hamburgers with everything, a cheeseburger with no pickles, and a cheeseburger with nothing but pickles, 2 more hamburgers with everything but onions on one, and everything but pickles, mustard, and tomatoes on the other, 3 large fries, 6 medium fries, 1 large fry, a junior fry, and 2 junior fries, 3 more cheeseburgers with extra cheese and bacon, 2 more junior fries, and a hamburger with everything, 2 more hamburgers with everything, and 2 more hamburgers with everything, 4 large Cokes and a large Sprite, 2 large Cokes and 5 large Cokes, and 1 large Coke and a small Coke, 3 small Cokes and a small Coke and a small Coke.
That's correct.
Great, here you go.
Thank you, sir. Listen up. Ordering 2 hamburgers with just pickles, 4 more hamburgers with everything, a cheeseburger with no pickles, and a cheeseburger with nothing but pickles, 2 more hamburgers with everything but onions on one and everything but pickles, mustard, tomatoes on the other, 3 large fries, 6 medium fries, 1 large fry, a junior fry, and 2 junior fries, 3 more cheeseburgers with extra cheese and bacon, 2 more junior fries, and a hamburger with everything, 2 more hamburgers with everything, and 2 more hamburgers with everything, 4 large Cokes and a large Sprite, 2 large Cokes and 5 large Cokes, and 1 large Coke and a small Coke, 3 small Cokes and a small Coke and a small Coke.
Okay, that's 2 hamburgers with just pickles, 4 more hamburgers with everything, a cheeseburger with no pickles, and a cheeseburger with nothing but pickles, 2 more hamburgers with everything but onions on one and everything but pickles, mustard, tomatoes on the other, 3 large fries, 6 medium fries, 1 large fry, a junior fry, and 2 junior fries, 3 more cheeseburgers with extra cheese and bacon, 2 more junior fries, and a hamburger with everything, 2 more hamburgers with everything, and 2 more hamburgers with everything, 4 large Cokes and a large Sprite, 2 large Cokes and 5 large Cokes, and 1 large Coke and a small Coke, and 3 small Cokes and a small Coke and a small Coke.
That's correct.
Coming up.
How many ketchups would you like with that?
Just one's fine.
Sure. There you go. Have a good day, sir.
Thanks, you too. Man, that hit the spot. My compliments to the chef.
Compliments to the chef.
Huh?
Never mind. What else can I get for you today?
What do you have in the way of desserts?
Ooh, we've got apple pie and cherry pie, Boston cream pie, and brownies.
I'll have a brownie.
Okay, that's 1 Boston cream pie.
I said a brownie, you idiot! Can't you get a simple order right?
Okay, hopefully you have things you're noticing and wondering about what was happening in that video, what I noticed is that he had a very long and very complicated order. Complicated order. So I wonder, why didn't he simplify it, make it a little bit easier on himself? Simplify. Okay, so why didn't he just say, I want 5 junior fries total, instead of saying I want 3 and then later saying I want 2 more? So why didn't he total up items that are the same? Okay, totaling up things that are the same is what combining like terms is. Okay, so we're gonna show you using this fast food example in the next slide. So we're gonna use some variables, H, C, and F. H is gonna be hamburger, C is gonna be for Coca-Cola, and F for fries. So if we go and order, let's say I want 3 hamburgers, and then I want a fry, and then I need 2 Coca-Colas, but oh no, I need 4 more hamburgers and 1 more Coca-Cola. Okay? It would be a lot simpler if we would just say, this is the total amount of hamburgers. So we need 3. Later on, we order 4 more. That's a total of, we need 7 hamburgers. Let's go to Coca-Colas. I ordered 2 Cokes, and then I added another one on. So I have 3 Cokes altogether. So I need to add 3 Coca-Colas to my order. And then if we look for fries, we only ordered 1 fry, so I have to add 1 fry. This expression right here, 7h plus 3c plus f, represents our order in most simplified terms. Okay, so combining like terms, what we're doing is we're adding terms that have the same variable, 4 h's and 3 h's, making 7 h's total. Okay, we're going to go through more examples. Are these like terms? We have 3 different terms, negative 3y, just y, and 5xy. So this one's a little different from the other ones because it has an x. It's actually not like terms with negative 3y and y. To be like terms, you have to have the same variables exactly. Okay? So really, the only ones that are like terms are negative 3y and y. Doesn't matter that one's negative, one's positive. We only care about the variables being exactly the same. Are these ones like terms? Okay, so this is what I was saying. It doesn't matter if things are negative or positive. Doesn't matter if they have a number in front of the variable. We just care about the variable. This is x, just a single x. This is just x. This is just x. All of them have just an x. That means they are all like terms. Okay, group like terms. We have negative 3y, we have 9z, negative 10, 8x, okay? We're going to group them based on their variables. So I'm going to do, here's where I'm going to put everything that has an x. So we have 8x. And we have negative x. Okay, well, this is 5xy. That's got to be a different group because it has variable x and variable y. Okay? Doesn't actually go in the group with x's. But we do have negative 5x right below that. So negative 5x should go in the x group. Okay, let's do a different group. Let's put y's over here. So there's this one, negative 3y. And then we have just this single y. Again, this 5xy doesn't count because it has to have x and y. It's not just the y group, not just the x group. It's its own group. Cross out because we already put it. Okay, we have terms that have a z. Okay, so we have a group. This is the z group. It's a bad z. Z. Okay, so 9 z's in this group. Negative 15 z's also there. Okay, what we have left over is this negative 10 and positive 37. These are called constants because they don't have a variable. But constants are in their own group. It's a group of anything without variables. Okay? So last group would be a group with negative 10 and 37. Technically, vocabulary word you'll need to know. These are constants. All right. Next slide. Okay, so here's a couple different methods to like show work for simplifying and combining like terms. First one is the shape method. So you look for like terms and you box them with like the same shape. So like here's 9x. Anything else that has an x, I'm going to box it in the same shape. So we have 3x. You always want to make sure you're putting the sign that's in front of the term with it. Okay, that's important. Then I'm going to do anything with y. Let's say we circle it. That's the only term that has a y. So then I'm going to go constants that are left over. So I have a positive 8, I'm going to triangle it, and a positive 5. So this is just another association stuff that's the same. Anything that's in a box, we combine together. 9x plus the 3x's, that is 11x's total. Okay? And then we have a positive 5y, and that was the only y that was circled. So we have a positive or plus 5y. Okay? And then the constants, the triangles, we have plus 8 and plus 5. That totals up to be plus 13 altogether. So here's our simplified expression, 11x plus 5y plus 13. Okay? When you simplify expressions, order doesn't matter. I could have written this totally backwards. 13 plus the 5y and then plus the 11x because 11x is positive. Order doesn't matter. It's still the same simplified expression. I like to work alphabetically, so I did the terms with x and the terms with y, and then the terms that don't have a variable, because it's called standard form. But as long as you simplify everything, that's the correct values, your order doesn't matter. Okay. Color coding method. Same kind of thing, just trying to show that using colors, these ones are the same. So let's say anything underlined red has an x with it. So we have 10x and 6x, but we're going to underline that plus sign in front of it because that is going with the term 6x. The signs in front go to the term behind it. Okay, that's everything with x, new color. Let's do yellow. I'm going to go to y's. So 4y with that positive sign in front of it. Then we have 5y with the positive sign in front of it. That's all the y's. And then I'm just going to go to my blue highlighter. Let's do the constants in blue. This plus 3 and this plus 5. So then all we have to do is combine our like color terms. So 10x's plus 6 more x's is 16x's total. Okay, and then 4y's, my bad, and 5y's is 9y's total. Okay, but we're writing this as one expression. So we're going to put that plus sign in front because it's a positive 9y, so we can actually see the terms separated by operation signs. And then my constants, I have a positive 3 plus another 5, which means we need to add 8 total. Okay, so here's another method. My favorite method is this next one, though. It's just rearranging all of the terms so that the like terms are next to each other. Okay, so I have this 9x at the start. Let's go to black. Might be easier to see. I have this 9x at the start. I'm just going to move the terms around so that this negative x, or subtract x, is right after it. Okay, so I have that written down. I have that written down. Let's go to the y's. I have this plus 4y I'm going to put next. And then I'm going to keep the plus 2y after it because those both had y and they're next to each other. So we wrote that down. And then we just have the plus 8 needs to come down. And then we have plus 6. So now all the like terms together, we can just simplify it. I have 9x's, take away one of them, is 8x's. And then I'm going to add 4y and another 2, which is adding on 6y is total. And then I'm going to add on 8 and 6 more. 14. So there is our simplified expression. Okay. Let's do one more rearranging method. We have 9x minus the 5x. And then I'm going to put the plus 7y minus the 4y. And then the plus 10 minus the 8. Okay, so 9x's take away 5 of them, leaves the 4x's. Then we're going to add 7y, but take off 4 of them. So we only have 3y we can add. And then we have add 10, take away 8, which really means we're only adding 2. Simplified expression right there. 4x plus 3y plus 2. Okay, which one of these, or which ones of these simplify to a single term? So the first problem, 5xy minus 5x, this has 2 terms in it, okay? So we're looking for the final expression is just one term, like just x, just 7, okay? So remember, because this has x and y, the 5xy, it's not a like term with something that just has x. We can't actually simplify this any further. It's as far as it can go. So this has one term, 2 terms, does not simplify to a single term. Okay? So we're starting out with this expression right here, 14 plus 3y plus 7 minus 3y. Starts with 4 terms. Let's simplify it. Okay, I'm going to go with my variables first. I have positive 3y, subtract 3y. Okay, start with 3, take away 3. That's 0y. I'm going to write it like that for a second. And then if we go over to our constants, we have 14 plus 7 more is 21. So I have plus 21. Okay, this looks like 2 terms. 1, 2 right here. Okay, but it's not, because 0y is nothing. This really isn't even here. So really, final answer for this is just the number 21. That is a single term. This one simplifies to a single term. Okay, so we go into the next example. 4x plus 9 minus 3x minus x. Let's combine all of those x's. Let's get a different color. We have 4 x's. Take away 3 of them, so we're down to 1. Take away that last one means all the x's are gone. Okay? I'm going to write 0 x's again. And then plus 9, that's the only constant. So really, all of this is just 9. So again, this one simplifies to a single term. Alright, last one. 8y minus 6x plus 2y minus 6x. Okay. Be careful with the negatives in front of the terms because I don't want you to think we have 6x minus 6x to be no x's left over, 0 x's. Okay? This is negative 6x because that term in front of it, and then a negative 6x again, which means we have negative 12 x's. And then for the y's, we had a positive 8y and a positive 2y, so you can see I rearranged the expression. And then 8y and 2y together is 10y. So this has two terms. It doesn't simplify to a single term. Okay. So you can count how many terms there are by just counting, okay, here's one thing, then a sign, another term, then a sign, okay? So the next slide was create an expression with at least 6 terms that would simplify to the expression 9x plus y plus 6. So we need 6 terms. We're going to need something and a sign. So there's our first one, second term, and then the sign like plus or minus, third term, symbol, fourth term, symbol, fifth term, symbol, sixth term. 1, 2, 3, 4, 5, 6. Okay? We can make this really easy. We can just break apart 9x. We could break apart 9x to be a ton of x's. I'm just going to break it into 2. Let's say we break it apart. So 9x was 5x put together with 4x's. That would be 9x's total. Okay. Plus 1y. I'm going to split this into 2 terms as well. Let's say we had 5y's, but then we took away 4y's. That would be 1y left over. I'm going to split 6 into 2 things. I'm going to do, it was plus 3 and then plus another 3. Okay? So my 6th term expression, which there's tons that would work, but the one I came up with was 5x plus 4x plus 5y minus 4y plus 3 plus 3. Okay? I can switch the order of all these around. So I have them kind of grouped by their variable, x's and y's and constants. That's how you can work backwards. Just make sure you understand combining like terms. Okay, that's the end of Combining Like Terms video. Thanks for watching. I will see you in the next video.